between a pre-image and its image after a dilation? Think about this question during the lesson. The landscape architect designs two open green spaces for an area of a park. She designs the larger space so the length of each side is 3 times the length of its corresponding side in the smaller green space. Where should the architect draw the larger green space? How can you use what you know about scale drawings to determine the space? The architect dilates the smaller space by a scale factor of 3. The dilation is a new type of transformation. The dilation moves each point of the pre-image along a ray through the point that starts from a fixed center. The dilation multiplies each point of the pre-image's distance from the center by a common scale factor. The point A' is in the image because it is on the ray, starting at the origin and passing through A. A' is 3 times as far from the origin as point A is, because the scale factor is 3. What property of a dilated image is different from the original image?
Select your answer.
The image of a dilation has the same shape, angle measures, and orientation, and the side lengths are proportional. The scale factor is the ratio of the length in the image to the corresponding length in the pre-image. We use r to represent the scale factor because it is a ratio of lengths. When r is not equal to 1, the image and pre-image are not congruent. The fixed center of this dilation is the origin, O. The dilation with fixed center, O, and scale factor, r, maps any point, P, to P' such that the length of OP' is equal to the scale factor, r, times the length of OP. For example, OA' equals r times OA. OB' equals r times OB. And the same is true for the other two pairs of sides. Now you know the relationship between a pre-image and its image after a dilation.
F', G', H', I' is the image of FGHI after a dilation with the center at the origin. What is the scale factor?
All right, so we have our original image here. This is our prime image. So we're going to look at O. And so O, we draw a line. It's not quite straight, but we draw a line. Can't get it to be straight. Straight enough. Okay, if we draw a line, our corresponding side length would be here, right? And so this is at 5. So our ratio of the side length will be 5 to, and that's a 1. So that is our ratio. So the scale factor is 5.
What are the coordinates of the image of ABCD after a dilation with center 0, 0 and a scale factor of 2?
Okay, so step 1. Identify the coordinates of each vertex of the pre-image. So we have A2 and negative 2. Prime would be A. So let me do a quick picture. So scale factor of 2. So I'm going to go through A first. So we're going to start at our origin of O, go through A. So scale factor of 2, which means it's going to be 2 times as big. So this would be at 4 for X. And I think about, let's say, negative 4 for the Y. So then this would be for A. And then for the next one, B, 2 and 1. And if I start from my origin and go through B, times 2, so that's also 2, so that'll be 4 and 2. Yeah, that'll more likely be 4 and 2. So 4 and 2. And then through C, that's straight. So through C, that would be 8 and 2. No, 8 and 0. So this would be 8 and 0. All right, and then the last one, D. Go through D. That's going to be times 2. It's going to be 8, and definitely going to be negative 2. So then this would be 8 plus 8 and negative 2. Alright, there it goes there. And then step 3 would be to graph it. They've done that here for us. A dilation with a scale factor greater than 1 is called an enlargement because the image is larger than the original figure, so it's gotten bigger. Similar figures have the same shape and angle measures, and the side lengths are proportional. So ABCD and prime ABCD are similar figures.
What are the coordinates of the image of PQRS after a dilation with center 0, 0 and a scale factor of 1/2?
So here we have the green and orange. A dilation with a scale factor between 0 and 1 is called a reduction. So it's going from this size to half the size because the image is smaller than the original figure. So step 1 is identifying the coordinates of each vertex of the pre-image. So here are all the coordinates of this original image. Step 2, dilate to find the coordinates of the vertices of prime PQRS. Multiply the coordinates by the scale factor. So 6 times 1/2 would be 3, 10, 5, and so on. And then you graph it. And then you get your scale down version or reduction of your original image.
A dilation maps point L, 3, 6 to its image L prime, 2, 4. Complete the dilation of figure LMN and label the image L prime, M prime, N prime. What is the scale factor? What is the length of side M prime, N prime?
Okay, so let's graph this out. So L is 3 and 6. That's what we have here, 3 and 6. And the prime is 2 and 4. So 2, and 4. So that would be the L prime. So then if I take, just from the original to the prime, my scale factor, would be 2 to 3 because my let me write that down. Write it here. It would be 2, 3. That'll be my scale factor. So to my numerator is going to be the new start of the new triangle. So, and 3 is from the original. So my scale is 2/3. So I would take the other points and multiply them by that scale factor, which is 2/3. So I'm going to take n, and my x for n is 6. So if I take 6 times 2/3, I would get 4. About 4. Where's 4? 4, and then 3 times 2/3. So 2/3 times 3. That'll give me 2. So I have 2 and, what did I say? 2 and, I forgot what I said. 6 times 2/3. 4. That's what I said. So we got 2 and 4. No, that wouldn't work. It would be 4 and 2, not 2 and 4. So there we go. And then we have M to be about there. You do the same, you multiply. And it's supposed to make my polygon. There we go. All right. So there we have our dilation, and then the length of side MN of the prime would be 2 units. So let's type in 2 units. Why is it doing that? So I'll type it on this side. 2 units is the length of M prime and N prime. There we go.